Hello grade 12, welcome to my channel, and let us have a look at this question, and hopefully it will help you guys to practice further and also to see beyond perhaps the level that you're being taught at currently. Now let's see. It's a very simple question proving an identity. So we have been asked a very simple question to prove this identity. So obviously, using the doctor's approach, we look for the complicated side, meaning through inspection, which one looks complicated here? Of course, fractions almost always present some form of complication. But what also makes it more complicated is that the denominator is given in terms instead of just a single term. There's two terms in the denominator. And if we look at this one, it's quite compact. Yes, it's still a fraction. It's compact. So usually when it's compact, it's not really the best one to go for. But not always the case though. Be very careful. Sometimes this may be compact, but in a very complicated way than the one on the left-hand side. So at least it looks like the left-hand side gives us more work. And so we can use the left-hand side to prove this identity. So we write the left-hand side is 1 over 1 minus sine theta plus 1 over 1 plus sine theta. Alright, so these are nothing but like terms. So addition of fractions, it's more like dealing with like terms. So we need to find the LCM, and the LCM is the lowest common multiple of the denominators here. So we simply just multiply the two denominators. Okay, so please guys, don't say LCD. There's no such a thing. Okay, you either have a common denominator, but again, even that word for me is like what? Because for me, when we've got, let's say, a fraction like this, let's say there's a 2 and then there's a 4 here. What is 4? Is 4 less than 2? No. So, in my opinion, it makes sense to say 4 here is the highest common denominator. Because of the 2, it is the highest, right? Because to say lowest, then it means we're choosing 2, but 2 does not divide 4 into a whole number. So that's, for me, a bit controversial, of course, but I mean, guys, try to find sense in what you say, though. Books are written by people, so people have been taught in a particular way. Some people don't question what they're being taught. They just swallow it up, even when it's absolute rubbish. They will go around say it with so much vigor and enthusiasm, and yet they're just insulting us, those of us who question certain things we do. Of course, there are certain misnomers we cannot run away from because we don't have better ones to use for the situation. But for the sake of having some sort of order, we then have to accept those as compromised as they are. I guess the LCD story, perhaps it's not too bad, but it's not correct. In fact, there's no such a thing called LCD. It's either you have an LCM or you have a common denominator. But even that, I would rather you say highest common denominator. But let's leave that, because many people can bring in a whole lot of distortions to this so that it all loses meaning. And at the end of the day, we reach no consensus. So for the sake of peace and direction or continuation, we'll accept that, but don't say it if you're talking to me, okay? If you are in our class and you go around saying such things, I am going to insult you. Please don't ask for it. It can come very fast. All right. Now, anyway, guys, what do? We say our lowest common denominator divided by that denominator, the first one. So these two will divide to 1. 1 is effectively invisible. So we're left with 1 plus sine theta. Then we multiply that to the numerator. It's going to be itself. So this is 1 plus sine theta plus we take our lowest common multiple. We divide the next denominator, and what happens? This bracket will divide that to 1, and it effectively disappears because 1 is as good as invisible. And we say this 1 minus sine theta multiplied by 1, it is going to be itself. All right, so now we handle like terms. We will see that sine theta will take sine theta, essentially they cancel. So 1 plus 1 is 2 divided by, now we see that this is a difference of 2 squares expanded. We shrink it. We always do a reverse operation. So this is going to be 1 minus sine squared theta. Okay. Then we have 2 divided by, we notice that this is the square identity, spelling out cos squared theta. And this is nothing but the right hand side. So essentially, guys, our identity is proven. Nice and easy. So where do we score the marks? Maybe for this step, yeah, and reversing this into that, yeah, and then using our identity there, yeah. So essentially, I'm not too sure, guys. The numerator, just to give more marks, maybe that would be okay. So this is very easy, fairly standard grade 11 question. But how could we take it to some metric level of it, and even beyond metric? Because I would rather, what happens if you are a brave student? You're like, no man, I'm done eating baby stuff. Now I want the real big boy stuff, okay, or big girl stuff. So now how do you survive trying to be a big boy or a big girl? Anyway, let's take it into this one right here. So let's say, okay, this is another option of dealing with this. How about we take the right hand side? We saw that this is going to be 2 over cos squared theta, right? Now this is equal to, we see that 2, we cannot really do much about it, but this is nothing but 1 minus sine squared theta from our square identity. And what do we notice? This is a difference of 2 squares. So this is going to be 1 minus sine theta into 1 plus sine theta. Those of you who know how to factorize this, please do know this and don't flinch. Now most students would get stuck here because they wouldn't know what to do. But remember, this, using the identity, it's a mark. Whenever we factorize, it's a mark. So however many marks this would be, at least you get away with 2 marks. And if this is 4 marks, literally, you have 50%. So nothing wrong here. But now what do we do? So guys, look at this. If we've got a fraction 1 over 2, for example, plus say 1 over 6, okay? Right. Now, let's just choose something that doesn't take 2. I don't want something that takes 2. Maybe let's put 3. Now, what do we do here? We get the LCM, right? The LCM is going to be 2 times 3. I'm just going to write it that way. I'm not going to write 6. But what do we have here now? This is going to be 2 divided by 2, which is 1. Then 3 remains. Then 3 by the numerator is going to be 3 there. Here we multiply, we divide this by that. The 3's divide to 1. We get 2. 2 by the numerator, this is 2. Can you see? This is what we end up with. So this means from there we get here, right? So this means essentially we can actually split this back into what we just did. So when we have it like this, it means we started somewhere and we ended up here. But now we're always doing this in reverse. So how do we reverse this back? So this is what we call now partial fraction decomposition. It's more like a dissociation of some chemical when you dissolve it in water into its respective ions. Take an acid, for example, a Laurie-Bronsted acid, or even an Arrhenius acid. So this is more like it. So we're always doing a reverse. So how do we reverse this into that? Because our target is to make it to look like the left-hand side. Okay. So this is the essence of what we are doing. So we want to say the first bracket divides something, the second bracket divides something, so that we have those. And we can already see these terms on the denominator. They are exactly the denominators right there. So we want to get back there. So how do we do it? Maybe let's move you up there so that you don't interfere with our work. Maybe let's move you a bit more and shrink you a bit. Take you out of sight and say, okay, this is our model right now. So in maths, guys, you need to know how to reverse things. If you are given the way forward, you want to take it the way backward. And of course, we continue like that. Now remember, guys, once we get here, we will say here, but we know that essentially 2 over 1 minus sine theta into 1 plus sine theta must have been the results of a situation like that. A constant a over the first bracket of the denominator is going to be 1 minus sine. Don't know why I always write in a hurry. Plus maybe b, this is a constant, of course, divided by 1 plus sine theta. So what did I call this situation? We call it the partial fraction decomposition. So these are concepts you might come across at varsity, first year mostly, or any calculus course. You will almost always have to deal with this. All right. Okay, all right. Now, what does this mean? Remember, what is the LCM here? Remember, now these denominators, there are 3 of them. And you can see this one can go into that, this one can go into that, and this can go into itself. So this is our common denominator, basically. Or we can say this is our highest common denominator, because of all these 3, this is the highest, and all of them can get into it. It's not the multiple anymore. So we multiply here by the common denominator. I'm just going to say common denominator, which is this one right here. So we multiply by this throughout. Remember, when we've got fractions on equations, this is what we can do. So when we multiply by this here, this divides to 1. So it leaves us just 2 is equal to, again, this, when we multiply there, the 1 minus sine theta will take out the 1 minus sine theta to 1. And eventually we have this one left multiplying the numerator. So this is a plus 1. Sorry, a into 1 plus sine theta. Plus, then when we multiply by this there, this one takes that to 1. And so we are left with that multiplying the numerator. So it's going to be b into 1 minus sine theta. Okay, so now this is nice and linear. So we can go to it nicely. So what do we have? We can say here, let. Now remember, guys, we go about it strategically. We can choose the value for sine theta because remember, sine theta is the variable depending on the angle theta. Since the angle is variable, the value for sine theta is the variable. But a and b are essentially constants. Okay, why do we know these are constants? Because they define a constant. So that's why we know these are going to be constants. So remember, within the very question, there's clues as to what should be what. Okay, good. So now we can say, now the technique of choice is to try and kill one of these brackets. For example, if we say sine theta is 1, You can say let sine theta equal to 1. Another student may just decide, you take this bracket, you equate to 0 and solve for sine theta. Then sine theta is going to come out as 1. Okay? So if sine theta is 1, this implies that 2 is equal to a into 1 plus 1 plus b into 1 minus 1. Now, can you see we've killed this because this is 0. 0 multiplied by any number is 0. So this is out. So this implies that 2 is equal to 2a. Therefore, our a is 1. Is it not coming out? Yes, 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 yes. Also, let sine theta equals minus 1. Of course, I'm strategically choosing here. If we did this the first time, we can do this bracket. We take this, we equate to 0 and solve for sine theta, we get minus 1. And what does this imply? It then implies that 2 is equal to a. Whether we write a as 1 or whatever, it doesn't really matter. But let's assume we didn't know what a is. So this is going to be 1 minus 1. Okay? Plus b into 1 minus 1 is going to be plus 1. Right. So this implies that 2 is equal to, remember this goes to 0, so this is just going to be 2b. Therefore b is 1. Voila, isn't it? That's it. That's it. That's it. So what do we say? We can say then we know that essentially 2 over sine, no, what are you doing there? 2 over 1 minus sine theta into 1 plus sine theta is essentially equal to 1 over 1 minus sine theta plus 1 over 1 plus sine theta. And this is equal to the right hand side, sorry, the left hand side. All right, so that's what we did, guys. So this one was a bit lengthy because it's a bit of a higher order approach, I guess, or should we say stuff that hasn't been taught in your level, but this is stuff you're going to have to come across. Remember, guys, when we are doing this part demands a concept of simultaneous equations. So that you can see. Remember, you can choose any value for sine theta, but strategically I didn't want to struggle with a lot. I just chose that I will let sine theta be, I don't know why this is there. I'll let sine theta be those two values because I'm looking at those brackets. That's the quickest way of solving it. But you can choose any value, but once you choose any value, you don't kill the bracket, right? I mean, you don't kill the next term. But what would happen is you will end up with an expression with two variables or unknowns. Then you can express one unknown by another. Then you choose another value for sine theta. It doesn't matter what it is. Then you get another equation. And in that equation, you can substitute the other one into the position of another unknown. Then you solve for the unknown and then plug it back, solve the other unknown. But at the end of the day, you will end up with these solutions there. Okay. So guys, that's essentially how you can take it back to the left-hand side from the right-hand side. But as you can see, it demands a bit of more knowledge of the subject, which you guys are going to probably learn at university or at some colleges, say from N4 upward. Because remember, N1, N2, N3 in our TVET colleges is nothing but grade 10, 11, and 12. So those are the equivalents of high school classes or grades, if you think about it. Then N4 is already higher than matric, so you probably learn these at that N level to N6 maybe. And if you're at varsity, then you will definitely learn calculus in this manner. Anyway, guys, I hope you enjoyed the video and leave a thumbs up. I will see you some other time. Goodbye.